So in order to find g double prime, we're going to have to find g prime first. And derivative of sine is cos. And it's a chain rule. And you can write it like that, or you can multiply the 2 times 5 and get 10 cos 5x minus 3. And then for g double prime, I'm going to imagine I already had the 10 out in front. Now the derivative of cos is negative sine, so I'll put the negative out there and have sine 5x minus 3, and then chain rule again times 5. So it would be the same as negative 50 sine 5x minus 3. If we had to integrate g of x, would be the integral of 2 sine 5x minus 3 dx. Working backwards, it would be a cos, but since the derivative of cos is negative sine, working backwards, this one's going to be negative cos 5x minus 3. And a chain rule would have us multiply by 5. So we have to divide by 5 and plus c. Yes?
If you know it continues, like go to g or the derivative of something, then our function would still be sine of cos, just living always.
Yeah.
They would be more and more stretched.
Yeah, we're just keep multiplying by 5s, right? And alternating between positives and the negatives, right? We're going to stay 2 positive, then 2 negative, then 2 positive.
So therefore, the slope is switching slower.
Yeah. And it's always multiplied by 5. Okay. Find the integral here. How many people saw substitution? Okay. When you start getting good at substitution, you start seeing, first of all, looking, is there a function inside of another function? We've got the x cubed minus 1 inside of the square root. That's your first hint. Then generally, what's the derivative of an x cubed? It's always an x squared. I mean, there's numbers involved, but generally the derivative of an x cubed is an x squared, and yes, we have an x squared there as well. So we'll make the function that we want to substitute whatever is completely inside here. So that's the first thing. We want to make it x cubed minus 1, not just x cubed, because we want to take the entire function that's inside of another function. That will give us that du is 3x squared, well, du dx, and then dividing by 3 will give us what x squared dx is. So now we can substitute in here, and we're going to have the square root of u divided by 3 du, which is the same as the integral of u to the half divided by 3 du, which if you add 1 to the exponent and divide by that number as well, plus c. And u, of course, is x cubed minus 1. Everybody okay with the 9 over 2? How I had the 9 over 2 as a fraction on the bottom, and then change that to a 2/9 by multiplying by the reciprocal? And now this one was very similar to your quiz. The 2 inside of the integral is the same as having the 2 outside of the integral. And since the integral from 0 to 3 is equal to 8, this is just 2 times 8, which is 16. And for this one, the function is being moved up 2, but as far as our integrals go, we can split it up. This we know is equal to 8. This is a definite integral, which if we integrate is 2x, and we can do that from 0 to 3. Plugging in that, we're going to get 8 plus 6, which is 14. Since you know that it's being moved up 2, if you have some sort of explanation saying that the function's being moved up 2, so that would add a rectangle with an area of 6, so therefore the area is 14, that's fine as well. And then finally for C here, now we're looking at the same function, but now it's being moved 2 to the right. Visually, we don't know what the function was. Well, that's not a function. Well, we know it was a function. There we go. And we know that from 0 to 3, that this area that area is 8. What's happening here is our whole function, if we think of transformations, is being moved 2 to the right. So if this area right here was 8, and we move this 2 to the right, what are these values now? C would have to be 2, and D would have to be 5. Yes?
Wouldn't our function have been a straight line parallel to the x-axis?
A straight line what?
Parallel to the x-axis?
It could be.
And our values would stay the same.
Then it wouldn't matter, but we don't know what the function is, right? It could be this one. It could be any function. And the fact that it's equal to 8 will only hold true if C is equal to 2 and D is equal to 5. And that'll hold true for any function. But if it was a straight line, it wouldn't matter what you would put, because the area would always be 8 for certain values.